Looking at this equation, we have a triangle and we have a square, and we want to know when the perimeter of the triangle will equal the perimeter of the square. I've written an equation to represent this scenario. Here's the perimeter of my triangle. I've just added those sides together. And here's the perimeter of my square. I've multiplied 2.5x times 4 since each side has the same length. So I could solve this by graphing, or I could actually also solve it by evaluating these algebraic expressions for a given value. Let me show you what I mean. So what I'm going to go into Desmos and type in the perimeter of my triangle. But you know what? Normally I use x. I'm not going to use x. I'm going to use a, because I just need a letter that Desmos is not going to interpret to be x, or my independent variable. I don't want it to graph it. There we go. So let's see. Does this look right? Yes. Oh, hang on. Nope. I have some x's in there because of habit. Let me change those to a's. Yeah, that looks good. Okay. And then on the next line, I'm going to have 4 times 2.5a. Okay, cool. The Desmos is saying, what are you doing? I don't know what to do with that. And that's because I need to tell it a value for a. So I'm going to choose -4 since that's answer choice F. That's right. A equals -4. And you can see when a is equal to -4, these have different values. These expressions do not have the same value. What about when a is equal to 2/3? Nope, they still have a different value. How about when a is equal to 6? Aha, there we go. Now they're the same. So then that means this 6 is the solution to my equation, because 6 is the value that causes the expressions to have the same value. And then, of course, answer choice J would also be wrong. So you can evaluate the values of algebraic expressions, and this is just another way to solve equations in Desmos. What if I didn't have answer choices? Then what would I need to do? Well, I would need to guess and check. So maybe I would start and say, oh, I think the answer might be 10. Nope. Okay, so then I would just guess and check. Let me see. What if I did 12? Those are further apart now, so I needed to go the other direction. What if I did 8? Oh, they're getting closer together, so I went the right direction. What if I did 6? Yep, there we go. So you can also use this with the guess and check method to evaluate those expressions and find the solution to your equation.